All right, here we go. Let's do example 5. So again, you need to get the bases the same. We can make both of these bases into a 2. Look what that looks like. It would be 2 to the 3x minus 1 is equal to, how do I write 32 with the base of 2? Well, it would be 2 to the 5th power. Once the bases are the same, you go ahead and you set the exponents equal to one another to solve. 3x minus 1 equals 5. So 3x equals 6. X is equal to 2. Look at B. Yay, the bases are already the same. So once the bases are the same, you simply set the exponents equal to one another. Bam, there is your answer. Next page is going to be a little bit more difficult. We've got all kinds of things happening here. All right, so here we go. We need to get the bases the same. Well, I can write 16 with a base of 4, so I'm going to use 4s. So it would be 4 to the 2x minus 5 equals, now this is 1 over 4 squared, which would be 4 to the negative 2 power. You have to be really good with your negative exponents here. Bases are the same. Let's take the exponents and set them equal to one another and solve. 2x is going to equal 3. X will be 3/2. Let's go ahead and do D. Remember, you can pause this video at any time if you need to catch up. So I can see that I can write 4 with a base of 2. So I'm going to leave this one. 4 with a base of 2 would be 2 squared. Bases are the same. Set the exponents equal to one another. So 2x is equal to 3. X is once again 3/2. All right, well now it's going to start getting a little bit more difficult, so take very careful notes. Pause if you need to. I can rewrite 125 with a base of 5, so I'm going to go ahead and I'm going to do that. So it'd be 5 to the x squared plus 8 equals 5 to the 3rd to the 2x. Well, now you have to employ the exponent rule that says if I'm raising an expression to an exponent, I multiply the exponent. So that's going to be to the 6x power, 3 times 2x. Time to take the exponents and set them equal to one another. I have a quadratic, so how do I have to solve that? Well, I'm going to bring it all over to one side, set it equal to 0, and get ready to factor. This does factor into x minus 2, x minus 4. So if I go ahead and set each of those factors equal to 0, I can see that there are 2 solutions to this exponential equation. They are x equals 2 and x equals 4. Now look at F. F's a little crazier. I hope you can see that you've got 3 different expressions. So we have really 3 different bases that I need to make them all the same. I'm going to make them all 3's. So I know that 9 is actually 3 squared. I know 27 is 3 cubed. And of course, my 3 is going to stay the same. Well, this is 3 to the 4x times 3 to the 3x squared is equal to 3 to the negative 1. Let's go back. If I'm multiplying 2 expressions, the rule says that I add the exponents. You have to remember all of your exponent rules. Equals 3 to the negative 1. Now I have the base is the same, so I'm going to go ahead and take the exponents and set them equal to one another. So obviously we have another quadratic, which I'm assuming is going to factor. So we're going to have 3x and x, 1 and 1, and it's got to both be positive. So if I FOIL it back out, you're going to see that I do get my 4x. So if I take each of those factors and set them equal to 0, my two solutions will be x equals negative 1/3, because I'd subtract 1 and divide by 3, and x equals negative 1. So that one's a little bit more difficult. Well, let's look at G. Now, my bases are E's, not a big deal. I'm still going to have to get the bases the same. So I'm going to make them all into E's, but I've got to use some exponent rules here. This 1 over e to the 3x, I'm going to make e to the negative 3x. And here I'm raising this to the 4th power, so I'm going to multiply the powers and get e to the negative 4x. We're going to multiply these two expressions, which means we add the exponents to get negative 7x. Now it's easy. Take the exponents, set them equal to one another. And if we just quickly solve, if I move over the 2x, it's going to be negative 9x equals negative 1. So x looks like 1/9. All right, finally one more. So I'm trying to cover every different situation that could possibly happen. Here, if you look at all of these expressions, I hope you can see that we're going to make the bases all 2's. So this would become 2 to the negative 1 to the x minus 5. This would be 2 to the 3rd to the x. And then this is simply 2 to the x squared. Multiply these exponents. So that's going to be 2 to the negative x plus 5 when you distribute. And this is going to be 2 to the 3x times 2 to the x squared. So when I multiply these, I add the exponents. So that's going to be 2 to the 3x plus x squared. And finally, I have my bases the same. Set the exponents equal to one another. So you'll see you did all of this in Math 113. So we're doing the same types of things we did there, but we take it one step further. We make it a little bit more difficult with the algebra. That's really the only difference. So again, I have a quadratic, so I'm going to have to set it equal to 0. So x squared plus 4x minus 5 when I move everything over to the right. Factor looks like it's going to be x plus 5 times x minus 1. Taking each of those and setting them equal to 0, you're going to get an answer of x equals 5 and x equals 1. So hopefully if you need to rewatch these, you are pausing the video. We're almost done with this section. We do have a quick story problem. Now the good news is story problems very often are plug and chug when you talk about story problems with exponential and logarithmic functions. So that should make things a little bit easier. So if we look at this application, between 12 and 1 p.m., cars drive into the drive-thru at the Citibank at a rate of 6 cars per hour. And you have this paper so you can read it, which is just 0.1 car per minute. The following formula from probability can be used to determine the probability that a car will arrive within t minutes of noon. So this is the formula that we're looking at. Notice it's an exponential equation because the variable t is in the exponential or in the exponent place. So the first thing it says is determine the probability that a car will arrive within a time of 10 minutes. So we want, what's the probability that a car is going to arrive before 12:10? Well, all you're looking for then is f of 10, which is 1 minus e to the negative 0.1 times 10. Okay, plug that into your calculator. Hopefully you're good at that. When you do that, you get 0.632. So that's the probability. So in other words, what this means to me is there's about a 63% chance that a car is going to arrive. If it's going to come between 12 and 1, it's going to arrive within the first 10 minutes. We'll determine the probability that a car will arrive within 40 minutes. So again, we're going to find f of 40, so you're just simply going to plug in the 40. And when you plug that into your calculator, you get 0.98. So there's a 98% chance that if a car is going to come during lunch between 12 and 1, it's going to come before 12:40. Also think about what that means. It means that there's a 2% chance that it's going to come after 12:40. You can also think of it that way. Look at C. It says, what value does f approach as t becomes unbounded in the positive direction? So as t gets larger and larger and larger, we started with 0.632, 0.98. What do you think that f is going to approach? Well, it's going to approach 1. And don't forget, 1 in probability speak is 100%, which of course there's a 100% chance that a car that comes between 12 and 1 is going to come before 1 o'clock. The graphing calculator, they're asking you, and I'm not going to do it because I hope you can do it, they're asking you to graph the function in your graphing calculator and then use your trace button. If you press trace, you can kind of watch the cursor as it traces your function, and it says determine how many minutes are needed for the probability to reach 50%. So as you trace your function, you're going to look at the values and you're going to look for when the x is at 0.5, or I'm sorry, when the y is at 0.5. Sorry about that, because this is the actual probability. And what should happen is you should get approximately 7 minutes. So there's a 50% chance that if the car is going to come during lunch, it's going to come in the first 7 minutes, which totally makes sense because don't forget it was 63% in the first 10 minutes. All right, I believe that is the end